Okay, previously we have learned about the techniques of evaluating limits. Now let's see infinite limits. Okay, so when you have a function, for example, f(x) to x equal to 2x plus 1 over x minus 3. When you substitute 3 into the function, then you get, when you substitute the 3 into the x, then you get 7 over 0, where fx is not defined at x equal to 3. Why is it so? Because a non-zero number divided by 0 indicates the presence of a vertical asymptote. Okay, so when you have a function, you substitute it with a value, then you get over 0, or the denominator is 0. Then this one indicate the presence of vertical asymptote. Apa tu asymptote? Nanti kita akan tengok. So for example, this one, this is the previous function you have. Okay, bila you substitute the x value with 3, then you get this one, 7 over 0, which is actually equal to infinity. When you key in into the calculator 7 divided by 0, you get maths error, okay, which is actually equal to infinity. So the graph looks like this, okay, this one and this one. Okay, satu belah sini, satu belah sini, because you have bentuk macam ni. Your function is macam ni, that's why you have this graph. Okay, and then what is this red line over here? Okay, this line is what we call as asymptote. Ni yang kita panggil sebagai vertical asymptote. It's because you have the answer is infinity. This one what we call as infinite limits. Okay, when you substitute into a value, then the value is over 0, or you get the answer like this. This is actually equal to infinity. So this is what we call as infinite limit. Okay, so you're going to have infinite limits, meaning dia tidak akan sentuh dia tidak akan sentuh x minus x equal to 3. This vertical asymptote is actually equal to x equal to 3. This red line. How do I know it is x equal to 3? Is from here. X minus 3, so you get it back. Just rearrange it, susun semula, bring your negative 3 to this side, become positive. That's why x equal to 3. So this one is your asymptote. Okay, vertical asymptote. Asymptote yang menegak. Yang mana this asymptote means your curve won't never be touched or won't never touch this asymptote. Dia tidak akan sentuh. It's getting closer and closer, but it won't touch this line. Okay, so that one is infinite limit. Infinite limit. Okay, you get the answer as infinity. Okay, now let's see limits at infinity. Just now is infinite limit. Now limits at infinity. Okay, limits at infinity means when you have like this, limit of a function 2 over x squared plus 4, when x or sx approaching positive infinity. Okay, you see that's the difference is the infinity is on here. Okay, not at the end, bukan sebagai answer, but as this one. Yeah, this one is limit at infinity. So how are we going to solve this? Let's see. So you have 2 over x squared plus 4. Then you're going to write it down like this. Okay, so you're going to divide it with x squared, and then this whole thing also you divide by x squared. Okay, you just divide it with, you pilih the one with a highest power. You add the x square, so you divide the whole thing with x square. 2 over x square over x square plus 4 over x square. So when you have this, you just substitute this infinity into this. Okay, so you get 2 over infinity, you get 0. And then x square, this one can cancel out, this one become 1. This one will cancel out, then you get 1. Okay, then 4 over infinity, you get 0. Okay, this one 2 over infinity, you get 0. 4 over infinity, you get 0. So 0 over 1, then you get 0. Bila you tekan calculator, you still get answer 0. But for this one, how about this? For this one, you have limit 4x plus 1 to x plus 3. Okay, so when you substitute this value of infinity into this x, you get infinity over infinity. So this is another thing of indeterminate form. Other than 0 or 0 over 0, infinity over infinity is also indeterminate form. So like I mentioned just now, you divide it with the whole thing with x. 4x divided by x. Why is it x? Because the highest power is x. Only x. There's no x squared, x cubed, x to the power of 4. No. This is only x. So you just divide it with x. The whole thing over here, you're going to divide by x. Each of this. And then you get 4x over x, you get 4. 1 over x, you just write it down as 1 over x. This one, 2x divided by x, you get 2. And this one, you can write it back 3 over x. Now, you can substitute it with infinity. Infinity, 4 plus 1 over infinity, you get 0. Any numbers that you divide into infinity, you get 0. For example, this one, 1 over infinity. Then you get this one. Okay, this one is 2 over infinity. Then you get 0. 2 over infinity. This one is 1 over infinity. This one is 2. This one is infinity. Okay, sorry. Then you have similar with this, 3 over infinity, you get 0. So now you can just solve it, you get 2. Okay, so again, I just want to recall that for limits at infinity, like this, limit at infinity, you will get the answer in numbers, 0, 2, 5, and whatsoever. But for infinite limits, like the previous one, you will get the answer either in infinity or you get the answer in infinity like this. Okay, so I hope you can differentiate between these two. Don't get confused. And for this one, this example, you have x minus square root of x squared minus 2, and then when you simply substitute the infinity into this, you get infinity minus infinity, which is also indeterminate form. Okay, so this is totally wrong. We cannot get indeterminate form. So what happens is that, remember, when you have surd like this, we're going to apply the conjugate, multiplication of conjugate method. Okay, so you're going to multiply it with the conjugate. So you see over here, x minus square root of x squared minus 2. So the conjugate will be x plus x squared minus 2. The only difference is that this one is plus. Okay, this one is minus, this one is plus. So again, this whole thing is actually equal to 1. Okay, this one you just follow the upper part. Okay, now you can expand it, kembangkan dia. You just multiply again, darabkan x times x, you get x square, x times this one, and then so on and so forth, you get this part. When you get this part, you're going to solve it. X square minus x square, just open the bracket and you get 2. Okay, up until this part again, you see you have the highest power is x to the power of 1, or x, only x. So why not you just divide the whole thing with x, 2 over x, x over x, and this whole thing inside the square root, divide by x, okay? Except for this one, because you have x square. So you're going to divide it with x square, okay? Okay, then you're going to solve this one. After you get this, you see you have 2 over infinity. You can substitute it with this value. 2 over infinity, you get 0. This one and this one can cancel out. Okay, this one can cancel out. This one become 1. This one also become 1. This one is become 2 over infinity. 2 over infinity, you get 0. So now you get 0 over 2. Where this one 0 over 2, you still can key in into the calculator, you get 0. But 2 over 0, you will get maths error. That's the difference. Okay. So still you get the answer. Okay, that one is limit at infinity. Okay, now we have covered about limits. Let's move on to the second major part, which is continuity. Okay, what does it mean by continuity? Is that a function f is continuous at a number a if limit fx as x approaching a equal to fa. Okay, dia kata satu function f tu continuous, bersambung pada satu number a tu if and only if limit untuk function tadi tu bila x approaching a adalah sama dengan function a. So there's a remarks there. It follows from the definition that f is continuous at a if and only if. Okay, dia kata dia ada 3 syarat so that the function is continuous. Fa is defined. Second one, limit of fx when x approaching a from the left and from the right exists. And the third one is limit from the left and limit from the right equal to fa. So in order for the function to be continuous, it has to follow these three rules. Okay, so let's see the first graph. There are a few graphs over here. Let's see the first one. You have a function y equal to fx. Okay, and this one is also you have a few function. Okay, for example, this one is straight line, and then you have another one which is also straight line but with the point over here, and then you have a disconnected line over there. You have one over here is one over here, and then also 2 disconnected curve, tidak bersambung, and this one is connected. Oh, this one is not connected. Okay, dia putus sampai sini and then they continue lagi again. Okay, this one is continuous. This one is also continuous. This one is also continuous. Okay, dia bersambung. The curve is bersambung. That one is continuous. This one is not continuous. Why? Because you get one over here and you get another one over here. This one is also not continuous. Tidak bersambung. Okay, this one is continuous. And this one is not, because they stop dekat sini and then they start another one from here. Okay, the example. The function fx equal to 1 over 1 minus x square is discontinuous. Okay, dia kata this function discontinuous. Tidak bersambung at x equal to plus and minus 1. Since fx is not defined at these 2 point. Okay, dia kata function ni tidak bersambung pada x equal to plus or minus 1. And then for b, we have another example. The function you have, what did we call for this type of function? This is actually piecewise function. We have learned it in chapter 1. This is piecewise function. Dia ada dua. Okay, so for the first function is for x less than or equal to 2, and for the second one will be x greater than 2. Okay, since we have two functions over here, which means that you're going to have two different values for the answers, then this graph is discontinuous. Okay, why is it so? How do I know that this is discontinuous? Is the first thing is that you have two different answer, and then the second one, remember when you have two different answer for the limit, one is from the left, one is from the right, that means your limit is not exist. When the limit is not exist, means that it is also discontinuous. Okay, so you have over here x greater than 2x. Let's see, the graph is like this. This is 2 from the right. This is 2 from the left. This is actually x less than 2 is actually for this part. This is actually greater than 2 is actually for this part. Okay. This is from the right. This is from the left. Okay, see it is discontinuous at x equal to 2. In fact, bila you tengok dia punya limit, left hand limit, you substitute the 2 into the function. This is left hand, 2 times 2 minus 1, you get the answer equal to 3. And when you check for the right hand limit yang ni, yang dari kanan, this one yang dari kiri. So bila you check yang dari kanan, 2, you substitute the value of 2 times 2 square, you get 4. So the answer is different. One is 4, another one is 3. This one is for 2 plus, this one is for 2 negative. Okay, this from the left, this is from the right. You get two different answer. So since the limit from the left and the limit from the right is not the same, therefore it is discontinuous. When it is discontinuous, mean the limit does not exist, because this one does not, you have different answer, not the same. Okay, where are each of the following function discontinuous? Di mana dia discontinuous? So you need to identify. For A, this function is discontinuous at x equal to 2. Because you have this x equal to 2, dia discontinuous dekat situ. Kenapa? Sebab when you substitute 2 into the x, you get 2 minus 2, which is actually equal to 0. So, okay? It cannot be defined. That's why it is discontinuous at x equal to 2. Okay, then you have the function for B, this one. It is discontinuous at x equal to 0. Dia detect, bila kita nampak saja this one is piecewise function, obviously it is discontinuous, because for piecewise function you will get different answer for each of this. Okay, so from limit from the left, since limit from the left equal to, okay, this one does not exist. Dia tidak wujud. And for this one, you have also the piecewise function. So what happened? when you have piecewise, it is discontinuous also at x equal to 2, because when you check for x from the left, bila you substitute, nanti masuk x equal to 2 dalam ni, then you get the answer equal to 3, which is not equal to F2. F2 means you directly substitute 2 tu ke dalam the function. This one is equal to 1. F equal to 2. F equal to 2 is this one. This is actually equal to this part. Okay. Dia tidak sama. Yang ni, you akan dapat the answer is actually equal to 3. This one, the answer equal to 1. So, dia terangkum dalam yang ni lah. Rules number 3. Limit from the left, limit from the right, not the same. And also this one. Okay. Dia not equal to FA. Okay, that one is for when the limit is discontinuous. You need to identify dekat mana dia tidak bersambung. Okay, definition 2, a function f is continuous from the right at a number a if, okay, dia kata dia bersambung dari sebelah kanan if limit fx equal to limit fx as x approaching a from the right equal to fa, and it same goes to the limit from the left. Okay, dia kata dia bersambung dari sebelah kiri atau bersambung dari sebelah kanan if this limit equal to fa. Fa means bila you substitute direct a ke dalam the function x equal to a. For example, okay, this one is using graph. Just now you just see using the function itself. Now you see using a graph. Okay, you have this graph. At which point A in 0, 1, 2, 3, 4, 5 is G continuous? Okay, so let's see one by one. Okay, for which point A in 0, 1, 2, 3, 4, 5 is G continuous. Okay, kalau syarat G, in order for G to continuous, it has to fulfill this condition, these 3 conditions. Okay, the first one, the function G is continuous at A equal to 0, 2, and 5. 0, dia bersambung dekat 0, 2, and 5. Why is it so? It's because the function G, kita tengok kenapa dia kata dia bersambung dekat daripada all these points, dia cuma bersambung dekat 0, 2, and 5 saja. Why is it so? It's because the function G is continuous at 0 since bila kita tengok limit daripada limit gx tu, limits of the function from the right, this is 0, right? Limit from the right daripada sebelah kanan is this one. Tengok, check the curve. Curve mana yang dari sebelah kanan yang menghampiri 0? This one. So this is actually equal to negative 1. Okay. So which is also equal to G0. And then the second one, the function G is not continuous at A equal to 1. So we're going to check it one by one. 0, 1, 2, 3, 4, and 5. Okay, then for at A equal to 1, is it continuous? So we're going to check from the left. Do you have anything approaching 1 from the left? Yes, it is actually equal to negative 1. Yang menghampiri satu daripada sebelah kiri adalah curve yang ini. Yang mana value dia is actually equal to negative 1. And how about limit x approaching this one? When it's approaching 1 from the right. From the right is this one, right? So you get the answer is 0. One is negative 1, one is 0. This is negative 1. This one you get 0. So the answer is not the same. So it's not continuous or discontinuous. And then let's see for 2. We check it for 2. For 2 over here, you have 1 from the left. From the left, curve dia daripada left, the answer equal to 0. Dia menghampiri 2, the answer bertemu dekat sini. So it is 0. How about from the right? So from the right, this curve, dia datang ke sini, then dia approaching, dia menghampiri, also 0. Okay, so 0, 0. The answer from left and right are the same. That's why it is continuous. Okay, then let's check for 3 at x equal to 3. Okay, at x equal to 3, from the left, ada tak curve yang datang daripada kiri? So you have this curve, right? The answer equal to negative 1. This one is equal to negative 1. And then this one, daripada kanan, you get here, and then pop, suddenly over here. Okay, the answer perhaps is negative 0 point something something lah. Negative 0.4 or 0.3 or like that, right? So the answer is not the same. And so that's why it's not continuous or discontinuous. It's similar with 4. 4, is there any... Okay, if you see 4 over here, the curve from the left adalah yang ini. Okay, this one. And the curve from the right is this one. Yang menghampiri 4 dari sebelah kiri adalah ini. Graf yang ini. And graf yang ini menghampiri dari sebelah kanan. So, does the graph have the same value ataupun yang touch pada value yang sama? Tidak. Kan? So, ini tidak ada. So, this one does not exist. Kenapa dia tidak exist? Because it is discontinuous. The graph itself, you can see it. Obviously, the graph is disconnected. Dia tidak bersambung. Okay, the graph. It's two different curves. One is on this side, the other one is on this side. That's why it is discontinuous and does not exist. And for G, bila x at a equal to 5, this one, let's check when it's from the left, daripada yang datang dari sebelah kiri, you get it, and yang datang dari sebelah kiri, anything, this one. And then G5, you ganti masuk je terus dalam function 2, which is equal to 1. Okay, so it is continuous. Okay, this is actually what we have discussed. So the answer is over here. The answer for the limit of the at a equal to specific number. Okay, you can check it back. You can try it on your own. Okay, now let's see the third definition. A function f is continuous on an interval if it is continuous at every point in the interval. Okay, dekat sini penting because it involve interval. I guess ada selang dekat situ. So dia kata satu function tu continuous dalam satu selang if it continuous at every point on the interval. Maksudnya dia akan continuous dalam satu selang tu, yang mana dia kalau dia continuous pada setiap satu point yang berada dalam selang tu. Let's say you have this selang this interval from negative 2 to 2. So, let's say in negative 1 or 0 or 1 or any points within this interval is also continuous. Okay. For example, show that the function fx equal to square root 16 minus x to the power of 4 is continuous on the interval negative 2 to 2. Okay, so solution. So kita boleh kata this is the selang, this is the interval, the a greater than -2 less than 2. Then we're going to use the limit laws. We have learned the limit laws before, which have 11 laws. Okay, so you have limit fx, x approaching a, as x approaching a. So you have this. Then what happen? This is using the limit law. Okay, bila you ada square root macam ni, you boleh write it down in this form. Terus buat square root the whole thing. And then you can just substitute it with the x value. Over here you have x equal to a. So you just substitute it with a. Okay, so this is actually, when you have this is actually fa. Kan macam kita solve for a function fa, you just substitute the a into the f. So it's similar with this. Therefore, by definition 1, the function is continuous. So bila you have like this, bila you substitute the x value with a, this is actually equal to fa. So this function is continuous. So definition 1 ni yang tadi, yang you have three different three condition. Okay, so then you have, okay, dia kata similarly, since the limit of fx of -2, for example, we use -2 from the right, -2 from the right. So what happen is that you're going to substitute the -2 into the x. Okay, we use the same function, you just substitute the -2 into the x, so you get 0. This is for f -2. And how about this one? Limit fx when x equal to 2 from the right. Okay, so this is actually, you're going to substitute the 2 into the x. Previously you substitute -2, now you substitute 2. Okay, so what happened is that previously you substitute -2, now you substitute it with 2, you get 0. So this is actually equal to f2. Okay, it follows that f is continuous from the right at -2 and continuous from the left at 2. Therefore, according to definition 3, f is continuous on this interval. Okay, why we only choose this specific -2 from the right, and the other one is x2 from the left? Okay, it's because dia dekat sini, dia between this range. Okay, so yang ada dekat sini adalah, you tengok this one, 2 positive, 2 from the -2 from the right. So this is -2. Anything from the right is within the interval. And this 2 over here, we choose it from the left, because anything that come from the left is within this interval. We don't want to see it this side, we don't want to see on this side. We only want to see within this interval. Okay, so we can both. That's why we only test for these two, -2 from the right and 2 from the left. See over there? This one is -2 from the right, -2 from the right, and -2 from the right. Yang penting dua-dua ni berada dalam this interval. Okay, we have another theorem. If f and g are continuous at a and c is a constant, then the following function are also continuous. Okay, so you have cf, f plus or minus g, fg, f over g. Okay, if you have a c is a constant and g are continuous at a and c is a constant. Theorem, any polynomial is continuous everywhere. Okay, Apa-apa saja bentuk polynomial is continuous everywhere. Polynomials means you have straight line, you have x linear function, that one is polynomial. You have quadratic function, you have x square, x cube. The graph is either like this, or the graph is either like this, or like this, or you can have a cubic line like this. This one is continuous. That's why it's continuous everywhere. Okay. Any rational function is continuous wherever it is defined. Okay, rational function is continuous wherever it is defined. There, for example, you have like this graph, you have one on this side, and you have one on this side. Okay. So dia continuous mungkin untuk curve yang ini, or mungkin dia continuous dekat sini. So itu maksud dia, yang wherever it is defined. Okay, in general, but for the polynomial like this, it is everywhere. Dekat sini pun continuous, dekat sini pun continuous, everywhere. But for a rational function, when you have a graph macam butterfly, okay, macam ni kan, satu dekat bawah, satu dekat atas, so it is continuous wherever it is defined. So kalau kita check for this point, it is continuous, but for this point, it is continuous also. But for this point, will it be continuous? No, kan? Sebab dia not connected. Okay, in general, the following is true. Theorem, the following types of function are continuous at every number in their domain, domains, polynomial, rational function, root function, and also trigonometric functions. Okay, for example, we have function 17x. This is polynomial functions. Okay, you see, this is continuous on this interval, negative infinity until infinity. It is continuous everywhere since this is polynomial. And then when you have this one, rational function, okay, dia dalam bentuk pecahan, x plus 1, x minus 2 is continuous wherever it is defined. Dekat mana? Dia bukan everywhere. Dia di mana? Tempat tertentu saja. For example, it start from negative infinity until 2, and also union with 2 until infinity. But it is not continuous at x equal to 2. Why? Because x equal to 2 will be the asymptote. This one we're going to be the asymptote. Okay, that's why the graph won't touch that thing. Dot x equal to 2. And then we have x over x. Also, this is continuous, but this one is also rational form dalam bentuk pecahan. So it is continuous wherever it is defined. Okay, dia kata macam ni, wherever it is defined. Dekat mana dia apa ni lah yang boleh. So you have negative infinity until 0 and union with 0 until infinity. And for 1 is continuous on negative infinity until infinity because it's just a constant. And when you have another one like this is also rational. So since we go back to this, any rational function is continuous wherever it is defined. So dia define dekat mana? Dia define dekat yang ni lah. Negative infinity until negative 2, union with negative 2 until 2, and also this one. Okay? And the last one is trigonometric function. So sama juga for trigonometric function, since it has a rational function over here. Ada bentuk pecahan juga dekat sini, so you will have, it is also continuous, but on this, only on this interval. Okay, so we have another theorem. If f is continuous at b and limit gx, x approaching a equal to b, then limit f gx as x approaching a equal to fb. In other words, it's written down like this. It's actually the same, it's just that this f, you just bring it at the front. Dia benda yang sama, cuma f ni you bawa ke depan, so you just rewrite it in this form. Okay, another theorem is that if g is continuous at a and f is continuous at ga, then the composite function f dot g given by this one is also continuous. Dia kata kalau limit satu function tu continuous dekat a, dia punya composite function untuk g, f and g also continuous. Okay, for example, the function fx, you have this trigonometric function continuous at this interval by the above theorem, because x squared plus 1 is continuous on this interval. You see this one? Ni adalah kuadratik. Yang dalam ni ada kuadratik. So, kalau kuadratik, dia akan continuous everywhere. Starting from negative infinity until infinity. And cos x is continuous also on this interval. For the second one, the function fx, this one involve square root. Is continuous on negative 2 until 2. Follow the above theorem because 16 minus x to the power 4 is continuous on everywhere, also everywhere. It's just that set x is continuous on this thing. Cuma yang ni saja masalah sebab ada set x. Remember in chapter 1 when we have set, we cannot have negative numbers. At least start from 0. Okay, kita tidak boleh ada punca kuasa negatif. It needs at least 0. Start from 0. Okay, until infinity. Okay, then this is the intermediate value theorem. Okay, this is the intermediate value theorem. Suppose that f is continuous on the closed interval a, b, and let n be any number between fa, fb, where fa and fb is not equal, then there exists a number c in ab such that fc equal to n. Okay, so this is intermediate theorem. So let's see the graph over here. So dia kata you have you have two closed interval which is a until b. Okay, so you have fa, you have fb. Okay, so there is another one, intermediate mean yang tengah-tengah. Okay, you have another one which is FC. Bila you substitute, tadi you ada A, FA and FB, and then all of a sudden bila you substitute FC, you get N. This one lah, dia ada satu lagi tengah-tengah. Same with this one, dia ada satu lagi. But that one when you substitute C ke dalam function itu. So now let's see the example. Show that there is a root of the equation. Root of the equation 3x to the power of 7 minus 2x to the power of 5 plus x minus 1 equal to 0, between 0 and 1. Okay, so you have this function. One can check that f0, bila you ada this function, dia kata between 0 and 1. Between 0 and 1. Okay. So what happened is that you gonna check, you have to substitute 0 and into the f and also the 1 into f. Now you substitute 0 into the function, you get negative 1. And then you substitute 1 into the function, you get 1. Okay, one is negative 1, the other one is 1. Okay, you see over here, f0, you get the answer less than 0, which is negative 1. And f1, you get the answer greater than 0, which is 1. Okay, from this, by the intermediate value theorem, it follows that there exists a number c in 0, 1 such that fc equal to 0. Since fx is continuous polynomial and 0 is between f0 and f1. Okay, dia kata ada wujud satu lagi number c in between 0 and 1. Okay. And then this is next example. Okay, dia kata show that there is a root of equation. So sama jugalah. Dia minta kamu tunjuk, buktikan ada root of the equation. Okay, so this one is your function. You check it. One is f1. You substitute 1 into the function and the other one is 2. Okay, so when you substitute 1, you get the answer less than 5, which is 2. When you substitute it with 2, you get the answer greater than 5, which is 514. Okay, so kita boleh kata 5 is between 1 and 2. This 5 is actually your C. Remember, this 5 is actually your C. This is your C. So, this is solution 2. Okay, you can check it for 1, substitute into this, and also you can substitute into this. This is another function. Okay, it's similar. You just follow the same with this one. It's just that the function is different. Okay, then you get the answer is -3. The other one is greater 5 or 9. And dua-dua nombor ni di tengah-tengahnya adalah 0. Okay, so 0 is in between -3 and 5 or 9. So 0 ni adalah dia punya C. Kalau daripada teorem ni lah. Daripada teorem ni dia kata ada C di tengah-tengah. That's why it's called intermediate theorem. Okay, so don't worry about the intermediate theorem. You just need to substitute the value into the function. Then you check for it whether one is less than this C and the other one must be greater. Okay, the last one will be limit from tangent line problem. Okay, this one is important. You have, for example, find limit this one, fx plus delta x minus fx over delta x as delta x approaching 0 if fx equal to 2x plus 3. Okay, now you need to find this limit when you are given fx equal to 2x plus 3. So solution is that, you see, this is given to you. This formula is given to you. So you need to substitute it. For example, you have fx plus delta x. So this is your fx. This is fx. So when it is x plus delta x, meaning that everything x over here, you're going to plus it with delta x. So for example, you have 2. Just originally you have 2x. Now you need to find x plus delta x. So it's become x2 times x plus delta x. Okay. Since this is this one. Plus 3. So plus 3, you don't have any x there, just write it back as plus 3. And then you're going to minus fx. This is fx. This one is fx. Okay. This one is fx plus delta x. You have delta x over there. And then you divide by delta x. Just write it down. Since we don't know what is the delta x, just write it down again, delta x. Then you can expand this, kembangkan dia, 2x plus multiply lah. 2x plus 2 delta x plus 3, and then this one you just open the bracket and then you solve it. Okay, this one you can cancel out, this one can cancel out, this one can cancel. Then the only thing remain is 2 delta x over delta x. Since delta x, 2 delta x divided by delta x, you get only 2. So this is the answer. Okay, that one is limit from the tangent line problem. I think that that's all for chapter 2, limit and continuity. And don't forget to subscribe my YouTube channel for more videos on mathematics lecture. Thank you.